Yes. Awesome. I'm Rui da Costa. I'm a software developer and tech lead. I've been around a while in Australia, in the UK, Switzerland. I've been using Python and Django for a long time. Been lucky enough to even have met one of the original authors of Django at the conference where I'm wearing the shirt for, actually, back in NeuroPython in 2009. I met Simon Willison, who was one of the 3 original developers. Please feel free to reach out to me, give me feedback, tell me what you like, what you didn't like, or ask me questions, or let me know what you like about Django, what good ideas for next time. What is Django? Okay, most of you seem to know, but the tagline, the web framework for perfectionists with deadlines. It's come about because the 3 people that started it had deadlines, and they were perfectionists. They were working in the publishing industry, specifically for newspapers, and that's how the development first came to be. They started developing in 2003, first opened it up to open source in 2005. So it's been around a while. It's a free and open source Python-based web framework, not a library, not a web server, and it's BSD license, which means it's very permissive compared to others. You just need to include information about where it came from, and you can build on top of it, which is one of the reasons why companies love it. It's fast. It claims to be. It can be if it's used right. You'll get some talks on some performance afterwards, but it's fast not just to run, it's fast to develop in. It's very quick to get up and running. You can follow a 10-minute tutorial on their website to bring it up to speed. I remember when Microsoft first launched their MVC.NET, and I was laughing in stitches for about half an hour because it took me about half an hour to watch the video that Django covered in 10 minutes. And you jumping in through hoops that involved quite a lot of repetition that was like, what's the point of this? It's fully loaded. That is, it follows the Python principle of batteries included, of including a bunch of things that you're probably going to need or want at some point, even if you don't need it upfront. Reassuringly secure. Some of you amongst us are in the security industry, and one of the things that was built into Django was that security isn't an afterthought. It's there from day one. It's there from the DNA of the library. That doesn't mean they're perfect, but it means they're very conscious of it, and there's a lot about security, some of which we're going to cover. Exceedingly scalable. Again, I refer you to my colleagues that use it at scale, and it's incredibly versatile. It's used in a broad range of industries for a broad range of things. Please go to the website. The slides are going to be shared, hopefully up on the website as well, so you can get to any of the links that you may be interested in afterwards. Some numbers. Well, this was a survey taken by JetBrains, who's a company some of you may be familiar with. They produce IDEs for a broad range of languages, but specifically from the Python subset, the 26,000 respondents answered that they use Django. Number 1, very close with Flask, very different. Talk a little bit about that hopefully later. But one of the most important things to note is it's been very, very stable. I mean, it's been around since 2005. It's still the leading framework in Python land. Okay, well, that's Python land. What about the wider industry? This is taken from the Stack Overflow survey. Much broader range of respondents, much broader range of experiences, people that may or may not be professional developers, people may or may not just be learning. But overall, I don't know if you can read that terribly well, but it basically has Django fitting in around the 12% mark or 11.5% mark, above Laravel, which was mentioned, which is a major PHP framework, above AngularJS, around the same ballpark as ASP.NET and WordPress, just below Vue.js, one of the popular JavaScript frameworks. Okay, that's all great, but who actually uses it? Well, you probably won't be surprised to note that coming from the publishing industry, Washington Post, The Guardian, which is where Simon Willison, that I met, was working at. So back in 2008, I was living, or had just finished living in the UK. There was a big scandal about ministers that had been expensing a whole bunch of things, and they very quickly, this was one of the first cases of crowdsourcing, where they basically opened it up to the general populace to review all the expenses that ministers, their local ministers, maybe other ministers, had been claiming for, and they wanted people to basically draw out items of interest that should be reviewed by journalists. They got this up and running within like a couple of weeks back in that talk. That was one of the things that drew my attention to Django at the time. NASA, I mean, NASA's a big corporation. They use basically everything. But just to be clear, in these cases, these aren't companies that use Django for 90% of their backbone. These are just companies that can or have used Django to some extent. But in the case of The Guardian, they did use it a lot for fast projects. For the Washington Post, they used it for, as far as I understood, for a large part of their engine for publishing their content at a time when people didn't have clean URLs. And getting back to that philosophy of perfectionists with deadlines, it was really about having clean URLs, clean content, clean structure in what was there, especially coming from a world of different web frameworks, PHP refugees and things at the time that wanted sort of some stability, some structure in their life. Discuss, one of the early social media pioneers for content to engage audiences in interaction, but also some more modern companies. Dropbox, where Guido van Rossum, one of the developers of Python, or the developer of Python, the benevolent dictator for life, where he went to work, Dropbox was also using Django. And there's quite a few that I came across, some of which I knew, some of which I didn't. Other companies aren't on here, like Facebook. But companies like Pinterest, I also met and knew that they were using it intensively as part of their core. YouTube reportedly switched from, did a rewrite from PHP to Python, to Django as part of maintaining their scalability earlier on in their development. And companies like DoorDash, Spotify, also using it. Links are there if you want to go take a look. Again, this is a hard area to sort of look at, like how much do they use it and for what percentage of their traffic, etc. It's a lot not disclosed, but there's quite a lot of evidence that it's still widely used. So how does it compare? Well, my first point of relevance, Django is a mature framework. What does maturity mean? It doesn't just mean old. It means that it's been around enough to have garnered a community. There's tutorials, there's books, there's even a conference. Unfortunately, it's down in Adelaide. But there's a lot of rich materials, a rich community, some of which are hopefully here as well, to contribute, to give back, to learn from, and that have evolved their usage of the framework. It's a macro framework, not a micro framework. So a lot of things like Flask and Fast API are really trying to do, they don't take the batteries included approach. They try to do a smaller amount of what's possible, try to be clean. Django takes the opposite approach. They provide a whole bunch of libraries and cater for a whole bunch of different scenarios, some of which we'll get to. It's modular and extensible, broken up into different parts, each of which is responsible for its own area, and each of those is extensible. Cover that a little bit and also touch upon it in the forthcoming talk about Django REST framework. For me, first and foremost, it's built on Python, which itself has a massive community. It's arguably one of the most popular languages, depending on who you look at, top 1 to top 5. One of the most eye-opening things for me was it was based upon an area that transcends just a programming language. And for example, some conferences I went to, when people were asked, you know, who's a developer, and it was only 10% of the room put their hands up because everybody else was coming from industry. They didn't consider themselves developers. They were SMEs, subject matter experts that were really using Python as a tool of choice to execute their business model or their work. Researchers, government operators, physicists, a whole bunch. And it comes from an ethos of stability. So unlike other languages, Node, NPM, these things tend to stay around for a while. So you're not likely to see a library that's the most popular one suddenly disappear. These things evolve slowly. They involve a lot of community input. They stick around for better or worse for quite a while, and they evolve, they adapt, and new ones sometimes come and take their place. But by and large, the things that were popular in Python 5 years ago, the libraries that were there, are still around today. If not, somebody has forked it, somebody has adapted it and continued to live it on. Is it for you? I recommend, one of the things that I like doing when I'm picking up a new tool or library is really take a look at the design ethos behind it. What is it for? What are their founding principles? And in there, they talk about things like modularity, talk about things like DIY, don't repeat yourself, things that may or may not suit your particular business or purpose for your project. Extensibility. I don't know how well you can read that, but there's a site called Django Packages. Up there, it lists that there's 4,000 plus packages in various states, but what I really wanted to highlight, there's a variety of different things, everything from form frameworks with Django REST framework, debug, extensions, things for interacting with serialization in different ways for GraphQL, a whole bunch. Authentication. My point is that stability, that longevity, that extensibility and modularity has resulted in its own community of stable yet up-to-date products that you can choose to build in. You don't necessarily need to have it there from day one, but the beauty of it is you can plug them in as you need them throughout the life. You want to have authentication and your business suddenly tells you they want to open it up to social media to log in with a Facebook framework. There's a library for that, you know, in much the same way as there's an app for that in iOS land. Chances are there's a library for that in Python or in Django or in Django REST framework that plugs right in. That for me was a key winner. It's an MVC framework, or rather an MTV. By that, the model in the M remains the same. MVC stands for Model View Controller. In Django, it's MTV, Model Template View. Both of them have models. A template in Django is what takes the place of a view. A view in Django, confusingly, is what takes the place of a controller. Models describe your data. Views control what the user sees. The templates are how it's rendered, how they see it. And the controller is what manages sort of the mapping between what you request and what you get given. So what's inside? We just covered the model, template, view. We have a forms engine. We have an object relational mapper. That is, you're not necessarily speaking directly to the database. You've got this framework within a framework that allows you to interact with the database, with the models, as objects in a Pythonic, in an object-oriented way. Taking over behavior, interacting with the behavior. We've got migrations that allow you to adapt to the changes in those models over time. And we've got fixtures that allow you to control the data that's there from setup and the well-defined items, things like seeds. We've got serializers. We've got internationalization. We've got pagination engines, authentication and authorization built in. Again, everything from Auth0 and basic authentication right through to things like other ways of doing SSO, right through to pre-shared keys or social media logins. We've got a web server for development to get you up and running quickly, to do hot reloads. We've got synchronous and asynchronous behavior and signals. We've got security frameworks from the ground up, cross-site scripting, cross-site request forgery, clickjacking, SQL injection. They're all catered for from the ground up. It's got its own testing framework. And it's got a whole bunch of stuff in the core libraries, none of which you need to necessarily use, but they're all there. If you start with an equivalent in Fast API or in Flask or in another micro framework, if your project evolves, you'll have to go out and seek libraries that you'll be able to plug in. With Django, these things exist and you choose to plug them in when you want them, and they're There's already a prescribed way for how to interact with them, how to work with them, where they fit in the model, documentation, videos, books, everything. For Google Sitemaps, for geographical information, for a whole bunch of things across a whole bunch of industries. There's middleware to do things like caching, to do things like throttling, to do things like conditional gets, so that as your project grows, functionality that you may want to use is there. And my personal favorite, the admin, which allows you to do the creates, the replaces, sorry, the retrieves, the updates, and the deletes on your database, so that you don't need to jump into the database. You've got a UI that you can interact with. How extensible is it? Well, in the example, we've got sort of the views that as you choose what to expose, you can subsume the behavior. On the right is an example of a dashboard that's done in the Django admin, completely overtaking the behavior, plugging in libraries that do rendering of charts, give you dashboards that show things in very different ways, just by extending over time the admin functionality. And plugging in libraries like Bootstrap and JavaScript frameworks that give you some of that rich client interactivity. Oops. Sorry, the obligatory animated GIF. Django REST framework. One of my personal favorites and one of the libraries that gives a lot of richness to Django, and it was high up on the list of libraries, but I just wanted to cover sort of the breadth of the areas that other libraries extend upon and allow you to extend upon to customize the different behavior within that, in a documented, in a supported, in a prescribed way that you can work with. Everything from over how serializers work, to how the authentication works, through to how we do content negotiation and schemas, creating client-side open API frameworks. We're going to get a little bit further talk about that. So here we are in 2024. Are those things still relevant? Are those things still of interest? Popularity-wise, it seems to be. But where's Django going? How do we use it today? Well, alternatives to things like Django REST framework exist, like Django Ninja. Does a lot of what Django REST framework does, claims to do it faster, simpler, newer, getting a lot of support. HTML extensions to do things that were previously only possible in JavaScript framework. Do you really need your JavaScript framework? There's plenty of talks out there on the internet where people are replacing front-end teams, masses of front-end code, with relatively simple server-side behavior extensions to HTML across languages, not just Python, not just Django, but basically the adaptability of the framework to broader industry best practices or potential movements. And where would we be in 2024 without a mention of AI? Arguably, Django being one of the most deployed, production-ready systems for delivering Python applications, delivering Python content, with Python being a key language in the data science space with frameworks like TensorFlow and PyTorch, many, many others that I've never interacted with. There has been a lot of work done in documenting how to deliver things into production using Django. You'll notice this is in 2021. So even back then, we were importing the future from Django. That's all I wanted to cover today. If you have any questions, let me have it. No questions. Alex? Suraj?
What's your favorite feature in Django in the last 5 years?
In the last
Best new
5
feature
years.
in the last 5 years?
Good question. From the last 5 years, I've kind of been reusing a lot of what's been there. Things like asynchronous, which I've personally not used. I have been doing predominantly synchronous work because the companies I've been working at, that's where they've gravitated, and REST APIs. Things like HTMX excite me because I was thinking, well, when is the right time as a backend engineer to look into replacing my perhaps outdated, but perhaps not from the numbers jQuery skills, and HTMX seems a logical place to sort of potentially pick up and, you know, overtake having to learn React or Vue.js, which seem to be quite heavy and not necessarily small learning curves. Yeah.
You see Django forms used to that. What's your take on that?
I've seen a lot of different forms engines plugged in for different purposes. My perspective, I've only been at my new company, Open Insurance, for a couple of months, so I'm still getting familiar with the code base. Beforehand, my last company, we had three Django REST framework applications as microservices, delivering things like delivery addresses and APIs for our supplier integrations and accounting integrations. Some of them as pass-through, some of them as primary systems. So we didn't really have a forms engine. Beyond that, sort of colleagues have used like Crispy Forms a lot to do a lot of the more, extend a lot of the behavior that is fairly basic within Django to have a little bit of more of a halfway house between what's available there and what's available in JavaScript-based web frameworks. But for me, that's one of the beauties. And one of the talks I really liked watching was from one of the developers, I think, of the co-founders of Flickr, when he gave a talk about what I hate about Django. And it was quite a facetious talk, but it was very, very interesting and very much in the early days. One of the things that was really funny is he complained about the fact that in Django you couldn't pluralize an object. Like everything came up as I think singular. No, came up as singular at the time and not plurals. And Simon Willison sat and put in a merge request while he was listening to the talk to extend the functionality to add it. That was really, really funny to watch. It's a very entertaining presentation to see, even though he's an American. Nothing to say about Americans, but it was really engaging to watch sort of something being twisted upon, you know, the things I hate, but here are the things I love, and this is how far it can take you. And it was really about, although there's all these things that are ugly about it, and it is a macro framework and opinionated in that way, it was good to be able to demonstrate how far you can get, how big your company can get before you start to outgrow or get pains around some of the decisions that are in Django, which even the authors admit, you know, they would have redone had they done it differently. But now with a big, slow, embedded code base, it's hard to necessarily undo those decisions without breaking things for others. And that's very much in the Python ethos, as you saw with the Python 2 to 3 transition, or with things like removing the GIL at the moment.
Do you have a database of choice?
Postgres. Postgres for versatility. It's not perfect for everything. I did work with MySQL, with Microsoft SQL, with Oracle, with quite a few databases. DB2 stick out to mind, but Postgres scratches a lot of itches, and I like the overlaps that it has with the Python ethos. So I've been to Postgres conferences where, again, you see people that come in from other industries, people that don't just have engineering problems, they've got business problems that Postgres scratches their itch for. And that's what I like, solving the business problem with engineering tools. You know, as engineers, we've got to remember these things, they're our tools, not our end goal. You know, our end goal is to make our businesses money, is to deliver value to the business. And Postgres is one of those tools in database land to do that. But there are some things about it that I prefer in things like Microsoft SQL. There's some things about MySQL that I like the replication behavior in MySQL is a lot simpler. Some of the things in MySQL are a lot simpler. Some things are also harder. Yep.
What don't you like about Django?
What don't I like about Django? The fact that it is big and old. like it would be nice to see things like, there's a lot of what is used and like the most commonly installed libraries that aren't yet part of it. There's things like asynchronous behavior doesn't extend all the way through to the database at the moment, from what I understand.
That's being worked upon.
Yeah. So cold fusion. But there's
this stuff exists.
The,
I mean, the async stuff that all exists in testing.
Yeah. For me, it's like what do you hate about big companies? They're big. How to put it? It can still be a lot to chew. It's not as simple to start up as a Flask or Fast API as well. Like, it is easy to follow the 10-minute tutorial and get something built up, but that can also give you a false sense of this is how it should be built. You know, the fact if you follow, in some ways it can be too easy to establish, to follow the code structure and build something which works for a long time, which may not be what you should be doing. Examples of that may be the settings. Examples of that may be, you know, not having caching from the get-go. There's a lot. But, you know, it's a tool. It can be used or abused, but like any other.
What do you think? I'll have more questions here. Yeah. What do you think about if we inverse the topic of your talk? What are reasons not to use Django in 2024? Do you see any use cases where Django wouldn't be a good fit?
Yeah, if you don't want to use Python, you shouldn't be using Django. Because that's what it is, and it's not a configuration engine. It's not WordPress where you just go in and fill it with content. If you want, I don't know, asynchronous only, if you want something super simple, maybe it's already too heavy. If your solution, your business solution, maybe can work on just Cloudflare workers or something relatively light. I think the SyDjango website doesn't use Django.
That's right. Do you have more question?
Using Django is
Did we let a HR person into here by accident? Well, I think having worked in finance for about 17 years, you know, although we say past performance is no indication of future performance, it's you pretty much always present historical information and draw the trends out from what's been in the past. So you see things like Fast API gaining some traction. Will it overtake? Will that be more popular? Personally, if the attraction of things like Fast API and having used Fast API are meant to be speed, I didn't see that much of a speed advantage in our use case where I was working in a neurotechnology company. If we look at things like clean design, well, it's as clean as you design it. You can make a mess out of anything. You can only simplify so much before, you know, complexity has to live somewhere. And if business needs a complex, then the solution will end up having its own complexity. Like anything, like any tool, it's easy to use and abuse. I still think Django's going to be around. I still think Django conferences are going to be around. It's interesting because as one of the authors that gave Django its name, actually Django's named after a jazz musician, Django Reinhardt, and Adrian Holovati actually wrote, or actually was in a video that's available online that I still haven't watched fully, but he talks about sort of reasons not to use web frameworks from the creator of one. So there's lots to consume and see where things are. But for me, Django is one of the reasons why I came to love Python, because it really showed the power and flexibility, readability, and concepts like separation of code, like solid, in its own element, and allowed me to deploy it in a number of very different use cases for different companies and industries.
Cool. More questions? Yeah.
what would be a feature that is really add value? One thing that's for the prospecting, what is bringing value?
I would love to see things like HTMX brought in closer. I would love to see things like the database library be for the ORM. I would like to support a wider set of drivers. There was particular pains around when we were using MySQL, for example, and having to ship binaries alongside of having to build stuff into the images in order to be able to get them deployed for the client. There's a lot of paper cuts. There's definitely things like, the asynchronous database work. There's no one particular standout. There's just a bunch of paper cuts, really. For me, I guess what I'd like to see is a continued evolution, a continued roadmap to draw a wider audience, a younger audience, people that maybe have made different design decisions in building out their framework on the client side because that's what they knew, that's what was rich. And maybe considering now with the advent of things like HTMX, that there's options to be doing that on a server side, a more centralized way that perhaps makes life easier for things like plugging in APM and monitoring and behavior of what the user's doing that are a lot more painful when you do it all the way to the client browser. With things like click blockers and ad blockers and extensions that change the behavior and make life difficult on the client side. But maybe that's just me as a back-end engineer wanting to see things move to the back end.
That's right. Okay, guys, let's give a big round of applause to Rui. If you want to speak to him more, you can do this in the end of the talks. I guess one thing that I forgot to ask you to do is to fill in the registration form. That was like some of the QR codes printed in the entrance. So if you haven't done that, I'll just quickly share on my screen. Okay, how do I stop presenting? And I'll ask you to pull your smartphones and fill in this registration form. Just for historical reasons, we want to, is it okay? Can everyone see it? Is it like scanning? Just for the historical reasons, we want to track the attendance. And yeah, there was a couple of questions in the form. If you want to be asked to provide feedback about this event, you can put the tick box in the form. And we also need to do this for the security reasons. So the building management asked us to do that. All right, we have next talk, Hashim. He'll probably, do you need time to prepare? Right? Okay. In a couple of minutes, while we are preparing, you probably have a couple of minutes to take toilet. I remember the toilets is on the left, from the left of me, in the end of the kitchen. Oh, I need to admit again. Okay. So now I can present. Do you want to use smart headset?
No idea.
Yeah, which one do you prefer? It will give you.
I've never done it.
Yeah, okay, so maybe this one is better because you don't need to think about. So you just. This is how I put it.
They don't need to do anything with this, right?
Say it again?
They don't need to do anything with this, right?
No, so you just need to put it in the.
Oh my gosh, yes. Hello, can you hear me? Testing. Hello.
It should be the switcher, basically.
Testing. Now it's working. Yeah, it works now. Yeah. Okay, I'll put this back in. Yeah, the entire screen is fine. Okay, yeah, I need to should be a PDF or somewhere. Yeah, this guy. This works. Yeah. Questions, yeah. Questions are fine. Yeah. This is working, right? Yeah. Yeah, the questions are fine.
Okay. So good to go?
Yeah.
Okay. Hey guys. Attention, please. So now we have Hashim speaking about concurrency in Python and Django. Very interesting topic. Let's give him a round of applause.
Right. Thanks, everyone. So yeah, basically concurrency, Python, and Django. My name is Hashim. I've been working with Python for roughly, like professionally, about 10 or so years, I think. And one of the things I've been seeing lately is Python has gotten somewhat of a poor reputation when it comes to concurrency. It's losing mind share in some cases to like JavaScript or Go, where the JavaScript folks, you ask them about concurrency and they say, well, everything is async and we have an event loop. And you ask the Go folks and they say, oh yeah, we can just do Go and like use the Go keyword with any function and it sort of becomes async. Both of those things, and like there's other languages that offer async solutions as well. And the thing with all of them is none of them are silver bullets. And Python has sort of caught up in providing an ergonomic API to sort of write concurrent programs with. So we'll see. So yeah, so a little bit of background. So this comes up very often because a lot of programs, especially web servers, so these programs, they involve a lot of waiting. Specifically, it tends to be waiting on the network. Sometimes it's waiting on the disk. And like traditionally, as in before async await, with Python code, it was a lot messier to deal with this kind of thing because Python would basically sort of run one line at a time, as like any normal program would, and it would sort of, the program would kind of not move forward until that network or file system, basically any input output procedure like function would complete. It would stop there and nothing else would run. And naturally in a web server, you have like many things coming in at once, right? You want many requests coming in at once. And the way to deal with this is traditionally has been using threads. So for example, if you run Django, like just Django run server without any other deployment sort of program, like there's Unicorn and Daphne and whatnot. So if you just do the plain Python Django run server, it gives you a decent amount of concurrency. It's actually pretty fast, as Rui mentioned. It simply spawns a new thread. And the trouble with programming with threads tends to be is you get all of these people with like a lot of experience scaring everybody away, saying, yeah, threads are horrible to program with, and there are like many things that can go wrong. So that's that problem. We'll get to kind of a little bit of why that is, but basically with async, with the new, I mean, it's not new anymore. It's been in Python for actually a while now, but like async await in Python is now reasonably, sorry, this keeps sleeping. I can stop presenting and start again. Oh, yes. Should I leave and come back? Oh, now it's there. Okay. I'll stay here and do this. Yeah, I should be somewhere. There we go. Yeah, thanks. So yeah, we like in Python, async await has matured. Django now offers async views, and this problem has kind of been tackled. And as we'll see in subsequent slides, we can do this. We can run these other lines that sort of do more things while there's one function that has stopped at waiting for a network request. By the way, like it's not, I mean, yeah, this other lines also, it's possible with yield, but it's not the same thing. Anyway, so yeah, solutions. So before, again, Python is very mature. All of these things, they were actually possible. It's just that anybody looking at the Python world from outside would be like, would sort of wonder what's going on. Why do we have all these different libraries? There's one called eventlet, there's one called greenlet, there's one called the-event, and there's probably a bunch more. And there's a funny function called, the-event.monkeypatch-all, for example. Like, what's monkey patching and why is it monkeypatch.all? And why does it have to be the first line in my program? So these none of these things looked good. You could have a very reasonably performant concurrent Python system with using these things that were already there, but none of them were in the standard library, and they all sort of had their issues, and it never looked good from the outside. And there's also this problem of you would get so sort of stuck into how to do this that you would kind of use these libraries and sort of pray everything works without sort of having a model of how your system is supposed to work. And why is it faster? Why is it not faster? What will make it faster? What won't? So without reasoning about these things, people used to try this and it wouldn't work. If you know what you're doing, you would have a better shot at fixing these things. But there was because it wasn't in the standard library, that same sort of ethos of doing things properly did not really come through. You could, as I mentioned, you could always just spawn new threads or new processes, but the problem there is actually because they're not sort of first-class Python resources. These threads are operating system threads, and they kind of exist in sort of a global space. There's no structure to them. You don't. You might be sort of leaking threads, and it becomes a bit of a mess. It's the same mess that you get when you have too many global variables that they're being mutated. So thread kind of led into that same problem. There wasn't any good way to structure them. They weren't first-class Python resources. They were just an interface to what the operating system provided. And threads can preempt each other. And reasoning about that preemption is pretty hard. So you get race conditions. Preempt means is just there's one thread running, and at any point, literally at any point in the code, it can get interrupted and another thread would run. Python would, like in Python, that's not too bad because Python forces sort of only one thread to run at a time. Like otherwise, If you have two threads that are actually running in parallel, then it's way more likely that you'll have data races. So then Python had this global interpreter lock, which again, people looking at Python from the outside in would wonder, oh, why is there a lock on the interpreter? Aren't locks bad? And just hand wave it away, which wasn't very, did not lead to productive discussions. So anyway, then async IO made its way into the standard library. It has taken years to sort of mature. It's now got a really good interface to actually doing concurrent programming in Python. So um, I like, as far as programs that are IO bound, as in they have to do a lot of interaction over the network, you can program those kinds of systems reasonably easily in Python now. Previously, it was much harder. And so what async IO basically did was, like, along with the async await syntax, is um, the runtime now comes with a scheduler, and it's the scheduler that can allow your code to run things concurrently. So the scheduler, when it encounters a function that's sort of waiting for some bytes to come in over the network, it will sort of park that function in its place until those bytes have come through. And in the meanwhile, if there's some other task that can be performed, it'll try and do that. So your program now becomes a lot more efficient, where previously you were just sitting and wasting CPU cycles or wasting, basically unable to do anything. Now you can just take upon more and more work and utilize your computer a lot more effectively. So, and yeah, so with async IO, it comes with a scheduler. It comes with this async await syntax. These await points, they're important because these are the only points where control can go from one function to another. That's sort of, if you understand this well, you can use this to your benefit. You have a very uh, sort of solid understanding of when will some other code run. It's like when this hits await. Until there's an await keyword, I have a guarantee this is the only thing that's running. So if you understand that well, you can use that to your advantage. If we have time to go through examples, we can sort of talk about this more. And yeah, the scheduler will then take care of resuming the program when it's possible. And most importantly, with now this scheduling, async, and await, these things and tasks being first-class Python objects, things that you can manage in Python, they work with things like there's the with syntax and the for syntax and these things. So now you can sort of think about your problem and program it uh, similar to how you would do with any other problem in Python. Like, you will want to structure it, you want to make your the right classes, separate concerns, and sort of fit the pieces together. You can do that now because you no longer have this problem of, for example, if you were using threads previously, this global kind of uh, list of threads that are just always running, and you have to find some way to communicate between them and make sure there's no race conditions and all that. Nor is there some, again, monkey patch all that just magically turns every function that uses a socket to a non-blocking socket and just does something with it. Um, so also, this is important. Like I said, you have to think about your system. You have to do things the way you would write any other program. You are sort of freed from having to worry about how some other library works and whatnot. It's in the standard library. So you have good primitives to work with. Once you've learned them, all you need to do is think about how your system should work and then try to model that with the primitives that Python and Django and whatnot these things give you. It If you don't do that, just the async thing doesn't magically make things fast. Like, I was once in a Rust workshop where when they introduced async, the way they did that was, and I mean, not to speak poorly of the person who was doing the workshop, they were extremely good. But even so, when they initially introduced async await, it was like a for loop with sort of one line in it, one or two lines, and one of them had an await. And that essentially didn't speed anything up. That's just that awake is the blocking call, and there's no concurrency actually going on. And that's, funnily enough, a reasonably common mistake, which it's it's easy to sort of jump on the bandwagon and think, oh, this is async, this will be faster. No, you really have to think about what you're doing and uh, write your program accordingly. um, we'll go over some simple motivating examples. One is concurrent uploads. It's a reasonably simple problem. We have a large, let's say we have one large file, not even multiple. But what we want to do is we want to break it apart and we want to upload it in 3 concurrent streams. I mean, could be more, could be less, but the point being, it's not an infinite number of concurrent streams that the number of chunks you get by dividing the file, you just throw them all, uh, as in you try to push them all over the network. You want sort of 3 workers running. Um, this is roughly what we'll do, right? And we won't actually be uploading anything. We just use sleep to simulate it for the purposes of a demo, and we won't actually have a file. It's just a string. Anyway, the point, like the architecture sort of the thing, like this system, the program remains the same. It's supposed to be reasonably simple, right? You have a file, you split the file somehow. You put these chunks in a queue, and you have 3 workers pulling things off of a queue and uploading them. You might be tempted to think, ooh, I need like RabbitMQ or Redis or SQS or like whatever, and have this process and that. If the language can, if the language provides you the context to manage concurrency, you can do everything in the language, and it all kind of just works. And you'll see this is, yeah, we'll switch over to code now. Should have probably given fair warning that there's code in the talk. Anyway.
Can you zoom in?
Yeah.
Thanks.
So you'll see that whole thing. It's essentially just 45 lines. And all we really need to do is let's start like top down. We have this main function that's taking a file and splitting it. Not splitting it, sorry. It's passing it over to this file uploader. File uploader is, it splits the file and it throws them into a queue, handily called queue. Then we have this max concurrent tasks. We create a task group. So like this will run as many iterations as the number of concurrent tasks we want. And that many times, we just create tasks with our worker function. Our worker function, so basically it's this diagram, right? We want 3 workers. So we loop over this 3 times and say start worker. And start worker is an async function. It pops something from the queue, and then the thing it pops from the queue is the work that it's supposed to do. And then it just awaits that work. And that is it. Like that's literally it. This implements that diagram above. We can run this. I would imagine. Oh, sorry. There we go. And you'll see it will print sort of 3 lines at a time, which kind of is coming in from here. Like the thing the thing that we're uh, doing is we're creating these upload functions. These upload functions are the functions that go into the queue, and they get picked up by this worker and awaited on. So a bit of breakdown as to sort of how this works. Your task is sort of your one independent unit of concurrency. It is these tasks that go on the tasks is what the scheduler knows about. Whenever you do create task, that's like a thing for the scheduler to potentially do. So we created basically these 3 concurrent things, and they there are 3 things. So the scheduler will basically run each of them, and we can safely do this queue.pop thing. You'll notice the queue is just a Python list, and there's no await with it. We just pop an item from the list, and we can do that. There's no race condition or anything because there's no await on it. If queue.pop were something that could potentially be awaited, then that would have put us in a little bit more trouble, because potentially other things could run, and it would then depend on how that async pop function works behind the scenes. But because it's not async, this whole thing works. So yeah, the number of things that we want to run concurrently, we make tasks out of them. We made and those tasks are simply async functions, and those functions do the job we ask them to do. Essentially, that's about it. One more thing, you will notice that we wrapped these tasks in a task group. Task group is something that came in Python 3.11. If you keep up with like concurrency features and programming languages, in recent years, there's been like development around this idea called structured concurrency. Task group is basically the Python standard libraries version of structured concurrency. This is how we avoid having sort of global references to concurrent things running here and there. Um, any any concurrent function that is started within a task group stays within the scope of the task group. When this with block closes ends, it will wait for everything that was started in it. It will wait for it to either complete or be cancelled. There is no way execution moves out of this with block without one of those things happening. So you don't have any random process leaks. You don't have um, I think there's a guy who had this blog post called "Go Considered Harmful" or something, where his the idea was that without the structure to your concurrent program, like threads and these uh, async functions were basically globals. They were basically go-tos actually, because execution could be anywhere in your program. Now you have this lexically scoped thing. Within this with block, execution is always in this with block. It is never outside of it. When it's outside of this, there's nothing from this with block that will stay running. That's a very powerful idea, and yeah, like this is one of the reasons I'm sort of hey, like to sell you the idea that Python has this, and for example, Golang doesn't. I mean, you emulate it with context and whatnot, but you know, this is pretty good. These you want to use these whenever you can, because otherwise tasks are in some sense a global set, and it's this task group that makes them nest and structure nicely and avoid all of these issues. So we saw how Python has these nice By the way, how am I doing for time? Yeah. So Python, as I showed you, there's a task and task group abstraction that's reasonably high level. But what if I want to do something more complicated, something that involves maybe coming up with a new um, set of functions that do something concurrently that I can sort of all compose in one function, package nicely, give to somebody else, but task group and task won't cut it, right? We need a more we need some concurrency primitive to make these things work together. Like what's task group using behind the scenes, for example? Who knows? Um, so we'll go on to our next example. Um, so before this thing called task group, I tried async await multiple times in Python, and there's a very good reason. This is the first time I'm giving a talk on this, because this task group stuff didn't exist. Before this, you had to use these lower level primitives. Again, but this is this is not bad at all. One example is you gather, and gather basically, like the docs will sort of say, um, it takes a list of um, functions and sort of waits until they all finish. But it's not as nice as task group. It doesn't handle exceptions that well. You have to sort of choose how you want to get exceptions, and there's there's some foot guns in there. But roughly, Gather was like the lower level version of um, task group. And this program essentially looks like exactly the same as the previous ones, not even more in terms of lines of code. But Gather is a bit, uh, has more complications. Um, so for example, if you were working in some language that had more, or like, for example, if you wanted to know what traditional concurrency primitives you would use, because this problem is very easily solvable by a semaphore for somebody who is familiar with semaphores. And indeed, you can. Like Python has semaphores, and you can just the example is trivial, so it's trivially solvable by using a semaphore. But um, the idea in showing you this is these things exist if you want to build something out of lower level primitives. So the semaphore is something that will it's basically two functions: acquire and release. Release increases the count, and acquire decreases the count. And the thing it gives you is, if the count goes to 0, acquire blocks, and somebody has to release from somewhere for the acquire to go through. This is often used to implement, um, for example, things passing messages to each other. It's like you can't receive a message until something's in the. For example, if you wanted to turn the list from our previous examples into sort of this concurrent and asynchronous kind of queue thingy, we would have used a semaphore. When the list is empty, the semaphore's value would be 0. Anybody who tries to acquire it would wait until somebody else increments it from the other end. From the other end, somebody else puts a value in, calls release. It goes from 0 to 1. The function trying to call acquire would take the value out. It goes back from 1 to 0. The next person trying to read a value, it'll block again. So semaphores of 1 are very common. In this case, we just use a semaphore of 3. That way, when 3 tasks are in, there can be 3 calls to acquire, and they will work. And then the next one will sort of block. Yeah, and because this is Python, we have the with syntax, which which sort of calls acquire and calls release at the end. Like Python generally comes with batteries included. This is one of the many ways in which you see this. There is an example later where we do not use this with, and we manually do acquire and release. We can see when we get there. All right. I think there's one more. Okay. This is this. You can see that this looks much worse. It's not much more in the sense of lines of code, but this is again using lower level primitives. And we implement the same thing that was in the diagram, but the difference this time is instead of having like a worker that's consistently alive and pulling tasks, we have we sort of have a coordinator that runs 3 things at once. And whenever something finishes, it replaces that finished item with a new one. So it sort of creates a new worker, and it maintains that status quo of always having 3 at a time. That's doable with this primitive called wait. So to walk through this, we basically split the file as we did. Then we maintain a list of what's in flight. We make a list of next batch and remaining, and we create this batch of 3 because max concurrent task is 3. The remaining is all that remains. By the way, this works for like for those not familiar with Python. This works whether this is 0 or 1 or 2 or 3 or whatever, because there's Python, this stuff works. Then basically all you do is, while you have stuff remaining, you have these in-flight upload tasks. There's a batch of 3, and while you have remaining items, you wait until the first upload task finishes. You always have to check done and pending are both lists. So if I say first completed, that doesn't mean done will actually be just one item. There could have been multiple things completed by the time code actually gets back here. So then you simply make your new next batch, your new remaining, your new in-flight tasks. In-flight are the ones that are up next, similar to what we did over here. We create an upload task for each of them. We add the remaining ones, and that's our in-flight list. In the next iteration of the loop, as long as we have things remaining, we check the in-flight list, wait till anything is done, and we move on. This sort of thing can be very tricky to get right if you're using, for example, threads and like threads and multiprocessing. You have this is a little complicated, but you'll see it's again very terse. If kind of once you get the hang of it, this becomes sort of reasonably easy to read, and it's much simpler than the alternative you would get with like processes and threads and whatnot. If you wanted to do something that's semantically similar to what this is, which is actually kill the thing, as in the process that was doing the pulling, you don't want to have 3 of them always up. You let one drop and you bring up a new one. If that is the kind of thing you want to do, this is way easier this way. You don't have any similar I mean, you have join, but then somebody will say don't kill the threads, and it just doesn't work out very well. Anyway, so yeah, we've discussed these lower level constructs: wait, gather, create, task. With these things and with task groups, you can implement most. So for example, back when even we didn't have task groups and whatnot, I did a chat server. It was wait basically that were doing most of the heavy lifting. Like there was a simple single file Python chat server. It served our needs at the organization at the time. You really don't need much else. You can do all these things within Python. To summarize and to sort of extract the recipe of what we've been doing so far, remember to model your system. You're not going to get anywhere without doing that. If you just try to sprinkle async await on your code and expect things to get faster or work, that's not how not how things are supposed to be done. You model your system, you decide how it's going to work. Then things that run concurrently and independently go in a task because the scheduler will switch between them. Things that share a scope will go in a group because that scope will sort of it exists within the lifetime of the with task group clause, and so they like that scope will get torn down together. So, like for example, you're writing a test runner, and you want to run some n number of tests together, assuming they're not CPU bound. That's a different issue altogether. But they will share a scope, they will share things, and you will want to sort of run them together, tear them down, and exit once they're all done. Communication between tasks should be decoupled. That's what we did with the queue thing. There was this initial async function that made a queue, and then the other async functions got things from the queue. They were not directly communicating. This is important to sort of achieve concurrency in the way that we sort of want it to work, as in this makes it if you weren't doing that, you would have the same issues that you have like scaling a system without a queue, for example. And simply just break this recipe down, break your design down recursively, and you get a program out of it, and it works. Caveats, this as you saw with the weight example, this is not necessarily easy always. It can be a bit tricky to get right. Always test your code, add in assertions, and you have enough tools in the language and in the standard library to work this stuff out. Make sure your code works in the case of exceptions. All the code that I showed you previously, if you add try catches in the right places, it works as you would expect. Like I did try it. I just removed it before I showed you guys to fit the code in one page. And yeah, make smart use of await points. Like I said, if in some sense it's very annoying, like an await could go anywhere. You don't know what else. You're maybe working in a large team, large code base. You don't know where execution could go after an await. But if you use them judiciously, if you kind of are mindful of the fact that okay, an await does this different thing, then you can decide to not use an async function there, to not await, and then it becomes a very powerful tool for you to reason about your program. You don't just add them in everywhere. We have one more example, along with, there's more stuff. Do I have time?
Sure.
Sorry, guys, because I know some people came from Central Coast to this meetup. So are you okay if Hashim will continue his talk? Yeah.
Okay, yeah. Okay, so streaming. So again, this seems like a very simple problem, and you have input from one place. You want to receive that input as fast as possible because so that you're not putting an undue burden on the person providing you that input. For example, if there's a browser that's doing a file upload to your server, if your server is unable to take in that input, the browser will have to sort of slowly keep sending stuff over the network, and not like it won't finish quickly. Maybe the guy has to, or they have to close the laptop and go somewhere. They can't do that. And you have an exporter because you want to take the stream in and you want to output the stream to another place. That other place may have the kind of issue that we're trying to avoid. Maybe that place is slow, or maybe you have a network issue, and maybe we cannot export as fast as we receive the data. So we'll put a buffer in between. And we have a receiver and exporter. I think in the code I call this an ingestor. But basically, we have these two things. This listens from that side, puts data in here. This waits until data arrives here, and then moves it forward. Well, how would we do this? There are many things we could do. So in this case, we made the queue a shared queue. Remember how previously we were working on a simple list? Now I decided, like, partly for the purpose of the demonstration, let's make this a queue, and partly because the system works better this way. Again, mostly for the purpose of demonstration, there didn't have to be two of these, but I ended up making two of these just to show that this works with the semaphore thing, and it also works in a different way. But the different way is this event thing. Event is another lower level object. So semaphore had a number associated with it, right? But event is really simple. Basically, you create an event, and then the other functions can sort of wait for the event. When the event happens, any function that is waiting for that event to happen will resume. It is as simple as that. So in this case, I'm using event to make this queue. The enqueue will set the event always. The dequeue, if it dequeues items to 0, it will clear the event. This way, the dequeue will always wait for something to be inserted. Whenever something is inserted, we set the event. If it was set or wasn't set, doesn't matter. It just works. Another thing to note, again, the use of async enqueue is not async. And we're doing these, we're reading an item and we're setting something, but we can do the without any race condition or whatnot. There's no as in you were trying to read something and somebody else came in and mutated a value. There's none of that happening because there's no await in between these lines. And this sort of ends up being a very helpful arrangement for us. Enqueue can be synchronous, dequeue can be async. Like the reason enqueue is it's helpful to make it synchronous is this way you have automatic back pressure. Like you go to some talk about these microservice systems and queues and whatnot, and like, ooh, these distributed systems, they don't think about back pressure. You really don't have to do much. If you sort of think about your system that from the outset, you know where you want to stop. So right now, this I think it's called a deck. This thing that's being used, it's a double-ended queue. Right now, this is unbounded. But if I were to bound it, like if I were to limit it to, let's say, 10 items, then enqueue will work until 10 items unless somebody dequeues. Now, after the 10th item, it will simply give back an exception. And we'll tell the user trying to push another item, like, oops, we can't do that. That's about it. I've gone over semaphores previously, so I didn't really need to have this example, but this is, again. But like this shows you that, as in, the release and acquire version of semaphore. So this is outside of the with statement. You can release as many times as you put items in, and you can therefore acquire as many times as you had put items in. Like, and when the final acquire will take your semaphore count, decrement it to 0, and then the next acquire will block until somebody releases it by doing enqueue. we have our ingester. An ingester just ingests the value. There's the incoming queue. That's where it ingests the value from. And there's the staging. This is the buffer in between. Staging is the buffer. The buffer is the queue classes that we just checked above, and it just enqueues in there. Similarly, the exporter takes stuff from the queue. Then we just wait a random amount to simulate, let's say, a slow upload, and it'll let it go. And finally, Steam. Steam takes these two things that are they're two independent concurrent entities, as we talked about previously on like in our recipe of how to do this. So we say we have at this level of abstraction and this high level just view of the system, we have these two things that sort of work together. They both go in tasks and they communicate using this shared queue. The input I was reading from the command line, you just write something, it goes through the enqueue, and then after a while, it comes out through the out queue in the right order. Like I can run this, and it mostly works. And you know the export thing, because it's waiting, it prints a while later, but that's about it. And here you'll notice the export is not doing multiple things at a time, because it is one task that is awaiting after each. There's one task that waits for its upload to complete, and then it goes to the next iteration of the loop. So remember, if we took the exporter from our previous programs and plugged it in here, then that would make our exporter work concurrently. And it could be in a task rope, and it would sort of crash together, as they like to say in the microservices world. It's like these things. What's the term? Blast radius. So the blast radius of the export will be limited to the exporter if we took the ones from the previous program and just plug them in here. But this is what I meant by acing await, not magically giving you like superpowers of speeding everything up. We have one task that is in a loop. It's awaiting on every upload. So that happens one at a time. But overall, this streaming system, it works exactly as advertised, in the sense of it takes input as fast as it can, and it buffers it in between and outputs it as fast as it can. All pure Python using both lower level and higher level primitives, they all work. There's two implementations of a queue. Those different queues are two different implementations, and they both just work. Okay, does this have anything to do with Django, by the way? Like, we have not mentioned Django even once so far. It does. As Rui mentioned, Django now has async await support. Yeah, it doesn't go all the way through the ORM. That does not matter too much when it comes to problems like the ones we just saw. And all of this stuff composes. There's a lot of things you might previously be using libraries to do this. Ooh, I wanna send emails, for example, and you might have like a separate task queue, like a separate service, and a separate worker, maybe Celery or some other library, Dramatic or something, that there's this whole separate library with its own workers, their actual processors, and they're taking stuff from the queue and putting. You don't need any of that. You can do all of that in your single monolithic Python program. You can make a module for your Django application, just include it, and have it all work. As long as it's not CPU bound, these problems are solvable. I think, like, so Rui was asked a question about the future of Django. There can be a lot more async stuff in Django if we make good use of these things, these features that are in the standard library. And we can sort of solve a lot of problems, like, because when we have these separate processes and threads and whatnot doing these things for us, then we have the problem of having to manage all of these things. When they're managed in the language, in the runtime, all of these things become a lot simpler. Like, if you ever go to an airline conference or like talk to some airline guys, they always go on about this, like, ooh, you guys use different libraries for these things. We just do everything in Erlang. We have our supervisors and this and that. We're catching up.
Yes, I think that basically what happens inside what is it basically Daphne would be that there's this library called SYDjango. So when they started working on async Django, they just implemented two methods in SYDjango, sync to async and async to sync. So if you were running a GeoNicon and kind of like it wanted to work within a worker, it would just await on top of that. And if basically you're getting in Daphne, you get the same request, it kind of like detects whether or not it wants to ship it inside, run it inside the main thread. For example, a synchronous field. And if it's basically not thread sensitive, then it gets shipped to a thread pool, which is very immediate because they're using a thread pool and running async workers.
That's a good point you bring up, because even the thing about then what do we do about synchronous functions, for example? If we have an IO function, but that's synchronous, don't we have this? There's a popular phrase that goes around like the function coloring problem. We don't. Like the example you just saw with the input stream was coming in from the input function. The input function is not an async function, but again, there's a wrapper in the standard library as well now. You give it your synchronous blocking IO function, it will simply run it in a thread, schedule it accordingly, and you can await on it. As long as it's not CPU bound, if it involves network sockets and things, or in this case, a simple Unix socket in which it receives things from the terminal, it works. And it works with the rest of your program. So and it's really, there's a lot of hard work that's been done by these the Daphne folks, the Django folks, the Python folks, and whatnot, to make this entire ecosystem sort of work like this. And that was basically it.
Cool. So we running significantly behind the schedule, unfortunately. So I'll probably skip the questions. But if you want to ask Hashim anything, feel free to catch him. And I hope you will publish your source code somewhere, so maybe people would want to look more into it. So while I'm preparing my talk, I just want to ask if anyone wants to announce anything, like maybe some open roles or I don't know, like any events or anything. No? Anyone? No?
I would like to advertise my library a little bit after this talk.
Okay, we have the open mic time now, Aaron, if you want to advertise it. Yeah. Go for it. Show us some code.
Hey guys, I work here in CG. I have this library that attempts to solve one very specific problem. Just one sec. I didn't prepare a talk, but I really like this library, so I want to share with you guys. Just wait one sec while I join the meeting. That's the code she used. Excuse me, no, you didn't invite me. Oh, sorry, one second. Oh, have anyone done anything like this in Django? Like when you need to take in an environment variable into Django as a Django setting, so you have to write os.environment.get or os environment, and or if you wanted to error out when the thing is not there, you might use the square bracket to access it. My library solves a very specific problem where I just hate repeating this twice in my code. So I created a library, which is it's called Ragdoll. In this library, you could create a class which extends the env setting built-in. I'll zoom in a little bit, sorry. So in here, you create a class that extends the built-in env setting. And then in there, I have already provided some primitive type in Python. It could be an integer, it could be a string, it could be a Boolean, where you just define your environment variable name on the left, just like how you would in a Django model. And then on the right-hand side, you could say what type it is. Could be an integer, string, Boolean. These are the 3 types that are provided in this library. And you could give it a default value. It basically is saying, if in the environment is not found, then use this value. And then you could import it from anywhere after the class is, basically if finalized after the class is defined. So after you import it, you could just access it like this, sort of like the Django model instance. And I made it easier to work with in Django as well. There is a Django env settings class in there. It has a little bit of magic where if you define as anything inside of this class, it would actually expose it to the global scope. So it will automatically be picked up by the Django. If you set the Django settings module environment variable to this file, it will be able to pick up. In this case, for example, the debug would be picked up as Django settings. So yeah, that's pretty much it for this library. If you guys like it, you could just do a pip install. The name is Ragdoll. Oh, I should probably mention why it's named Ragdoll. Coming up with a name in PyPy that's not used is very hard. So I just looked it around when I created this library. My cat is right next to me. And it's a Ragdoll breed. So this library is called Ragdoll. So yeah, that's pretty much it. Any questions? Okay, thank you very much.
Well, thanks, Aaron. And this is exactly what we want to do with this event. We want people to come and advertise the things that they're working on. So yeah, I guess you know, the library that Aaron built is different. It's a different approach than the other configuration libraries that exist, and yeah, I think it solves some specific problems that we might have in some applications. So yeah, if anyone wants to give like a quick talk in the future, 5 minutes talk, like feel free to just come. Probably we will build a form where you can register those talks in advance. But yeah, if you just want to speak quickly, you don't need to prepare a presentation. Feel free to do more of that. Okay, so the last talk for today is sorry, that's my presenter view. Okay, that is much better. So the final talk of today is 8 simple techniques to make your GRF API faster. The reason why I decided to cut it off to 8, because the 2 of them were actually not such a simple topics. And once my presentation was ready, I realized I probably want to take them out just to make the presentation shorter and be conscious of time. So only 8 today, and I'm focusing on Django DRF, but many of these techniques are working for other frameworks as well. And today I have my former colleague from Datalicious, who we worked with 13 years ago. So we finally met today for the first time in real. Back at the time I was working in Ukraine, so Jeremy. And I remember how we optimized the performance on a Symfony application. And that probably was my first experience. And many of the things that I'm speaking today, they also would be probably relevant to Doctrine ORM that we used back at the time. So my Django experience is mostly based on working on a large insurance distribution API. This code base is approximately 6-year-old. It has around 150,000 line of code, Python code. And right now, this application is serving approximately 15 million API calls per day. And our partners put this application in their booking pass. That's why we have quite strict performance requirement for this application. And while working on these apps, I and the team, we actually had to solve quite a lot of performance issues. I won't be able to cover all of them today. So today in my presentation, I just wanted to focus on those of them that you can implement easily in your application. So I wanted to do this talk very practical. And but before we jump into those optimizations, I want to speak quickly about the importance of measuring performance. So you can't improve what you can't measure. And there are multiple different ways of measuring performance, but if you would choose, if you would have only one tool that you can choose, that definitely should be application performance monitoring framework. At Cover Genius, we use New Relic APM, but there are many other solutions like Datadog and Dynamics, Dynatrace. Sentry has some APM features these days. So all of them are different, and but yeah, at least one of them, if you are working on performance issues, will be very, very useful. So this APM tools that allow you to measure performance from in production from inside of your application, and they give you some base metrics such as throughput, latency, and error rate, as well as some advanced metrics like the number and duration of your database operations, external API calls, and so on. Another way of measuring performance could be synthetic monitoring. So synthetic monitoring is a technique in which some script is running on a scheduler, and you can run it from a different location and measure response time. This technique is useful to measuring uptime, or you can also use it to estimate network latency. We also use New Relic synthetics, but other popular tools are Pingdom and Postman monitors, especially for APIs. Performance testing. So we at the moment we're using K6 at Cover Genius. It's a modern and popular tool. It is backed by Grafana, and that's why I think it has a bright future. Grafana is a large organization, so it's available as a part of the Grafana Cloud, which is a kind of a paid offering. We use the open source version of it that we deployed ourselves and implemented that in a way that we run our performance testing from distributed Kubernetes, distributed pods in Kubernetes clusters. So you can generate quite large volumes using K6. And in the past, we used another tool that I also like a lot. It's called Locust. So Locust is a tool that is written in Python, and it basically implements a Pythonic approach to measuring performance. But there are other solutions available. But these days, probably for a Django application, I would recommend just this two. And finally, the way of measuring applications in your local environment is profiling. There are Django-specific profilers. We use Django Debug Toolbar plus a set of plugins, but other popular Django profiler is Silk. You can use this, and as needed, we use some other specific providers to optimize profilers, or to optimize memory, or CPU usage. For example, cProfile or memory profiler. And there is also a tool that I can recommend that is called PyPerf. It's used to benchmark Python code in it gives you like a nice structured way of collecting those benchmarks, and especially when you testing some library performance, that's very useful tool that you can use. So now once we have tools in place, let's jump into this optimizations. The first one is the simplest. It's also my favorite, because everything that you need. You might, some of you, especially those who are not very experienced in Django might not be aware that Django by default opens and closes database connection on every request, which is less than efficient because opening connection is an expensive operation, and basically, if there is a way to reuse this connection between requests, it should be used. So this is exactly what connection maxH option does for the data in your database settings. So in this case, the connection will be opened once and reused up until 10 minutes. That's very easy. Just changing one line of code, deploy it, and you get the and then in your monitoring APM tool, you can see how your response time decreases. The one more option is would be useful to ensure that these connections stay usable, because sometimes your connection might become stale. For example, when the database server is restarted or master failover happens. So in this case, it's usually a good idea to check if the connection is in usable state. And this is what Con health check option does. It was introduced in Django 4.1, if I'm not mistaken. So pretty new, and everything that it does, it just runs a simple query, select one from the connection. And when if it passes, then the rest of your logic is performed. If it doesn't pass, then the connection will be recycled and the new connection will be created. So cool. Next technique is allows you to improve the DRF serialization performance. Serialization might be like a bottleneck, and so for some applications, and the standard JSON library in Python is not very fast, and there is a better alternative that is called OR-JSON. So OR-JSON is basically a JSON library that is written in Rust, and it's much faster than the standard, and it's also implementing the completely all the kind of features of JSON standard. It's fully compliant with the standard, so you safely can use it. And there's this small package that is called DRF or JSON renderer, but it's not a popular library. I think it's only like 50 stars on GitHub. So if you want to use that technique, if you have this problem, you can just look at this source code of this library. It's really easy to do. Everything that you need to do, you need to implement a renderer and a parser, and then you can use that in your DRF configurations like this. You just specify this renderer and parsers. Cool, let's move on. And the next thing is really, really simple. It's upgrading your Python and Django. Might not be that simple for some applications, but if you get good testing coverage, you can get things done pretty quickly. In addition, if you want to use some specific tools, if you want to automate this upgrading process a little bit, you can use such tools as PyUpgrade or Django Upgrade. They actually will modify your code and help you with the transition. That they will patch your source code automatically. We actually use these tools. We install them in pre-commit hooks, and once you put this configuration in place, yeah, it's pretty much everything that you need to do. Pre-commit, run -a, name of the hook, and see all the changes done. If you test passing, you can release this in production. Python 3.11 comes with a huge performance improvement. Once we released Python 3.11, we saw quite significant decrease in response time for our application. I think it was at least 15%. It's not the case. We haven't tested Python 3.12 yet, but actually, it seems that the situation is not as good. There is not such a so benchmark shows that some of the tests run faster and some of the tests run slower. So it doesn't always give you performance benefits, but it's still like a good idea to keep your application upgraded to the latest version of the framework at all times, and it can give you this performance benefits. Cool. So the next thing that I wanted to talk today about is minimizing the database writes. So one way of minimizing them is if your application is using batch operations. So there are two methods, bulk create and bulk update. This is query set methods that allows you to combine multiple operations in one single SQL query and which runs more efficiently. But in general, if you can design your application in a way that there are less tables that your application writes to, it also could be a good way and will future-proof your application performance. One quick thing as well is when you optimizing database, right? Like you need to be conscious about database indexes, because indexes can slow down the write operations. So yeah, don't overuse indexes. If you don't need this index, don't put it in your configuration. Let's have a look at how you can use this database batching. So let's have a look at this code. Very simple code. You iterate on the list of objects, models, and you basically save each one of them in the database. This will cause a separate SQL query every time an item save is called. You can replace it easily with this code, which also less lines of code, but it also works much more efficiently. Now the next technique is skipping instance creation. So ORM is good. It's very useful. It operates with objects, but ORM could also be the objects can also be harmful to the performance of your application. So sometimes you can get a significant performance improvement if you skip the instance creation, especially if you're if it's a get endpoint and you not planning to change your data. So values and value set query set methods, they exist exactly for that reason, to help you to kind of avoid using objects and allow you to kind of take data from the database and create simpler data structures that are faster. So in this simple example, you can see using the value list that you can, if you only need an ID of records, then you can just use values list with argument flat true, which returns a query set that contains just IDs. And it's much smaller in size, and it's much faster to iterate it on that query set than on a list of objects. So you can also float some computations to the database. So in this example, we use annotate, and then we use values list that picks that kind of annotated field. In this case, all the computations are happening in SQL itself, and we just like fetch the result from the database, which might be, in many cases, much more efficient than running those computations in Python. Yeah, in the result, we receive a query set that contains a list of tuples, tuples even works even faster than dictionaries because you don't really have the keys, and it's smaller in size too. The next one is famous or infamous, the N+1 query problem. It happens when your application iterates over a list of objects, and then for each object, it fetches a dependency. So in GRF, it quite often happens when you're using a serializer with like nested serializer with many true. If you don't prefetch your data, then that will result in for the new objects to be pulled from database one at a time and result in multiple queries. So let's have a look at this simple example. We have a list of, so we pull from database a list of users, and then for each user, we need to pull a list of posts. So we do this in a separate query, and if we just don't use prefetch, that code would result in 11 queries. using prefetch related, though everything that we changed with the previous slide is prefetch related. But now what happens is that Django will pull this data in all the related posts in one go and join them in Python, and that will significantly improve the performance of this piece of code. You can also use select related. So the difference between prefetch and related and select related is the level at which the joining is done. So select related does this in SQL, whereas prefetch related does this in Python in memory. So yeah, this code will result only in 2 queries being performed. And if you use select related, that will be just 1 query. Prefetch related is actually a very powerful method. It allows you also to use prefetch objects for precise control on what data you want to prefetch, because one danger of using prefetch is that if you fetch in too much data from the database, you can use all your application memory, which you don't want to. So you can put like limit in your query and using the prefetch objects, and you can also save results without overriding the main kind of relation attribute. So you can save your results to a new attribute. So that technique is kind of very powerful. Yeah, I'll jump to the next one. It's the problem with under and overfetching. So overfetching is basically when your application is pulling more data from the database than it actually needs to process the request. And basically underfetching is the opposite of this. When you originally it happens in ORM when your piece of logic doesn't take from the database all the needed fields and need to perform additional queries to get this additional data to process the request. So both are harmful for performance, and yeah, and basically you can use query set methods only and defer to specify the list of fields that you want to take from the database, and defer is the opposite, the list of fields that should not be taken from the database. There is a danger. So once you optimize a piece of code, so yeah, in this example, I try to show how this underfetching problem happens. So basically, originally we only use maybe user ID field, but then later in some piece of code we use another attribute from the same model. And in this case, Django will perform an additional query to fetch this field. And if you do this in a loop, that will be 10 additional queries that can negatively impact the performance, of course. And like the way to control this is, you can use the capture queries context in your tests. That gives you full access to all these queries that a block of code is performing, and then you can analyze them and perform some assertions on that stored SQL queries. So in this case, for example, if you optimize an endpoint or you optimize like a significant block of code, and you can put this assertion in your tests, and you can ensure that this piece of code will stay optimized, because if your code will start performing more or less queries, that will change. I thought about building a library to do this automatically. It should be relatively easy to store this in some sort of file, and then that would give you exact information, how many SQL queries and to what tables each of the tests perform. Then you can have a baseline, and then just, yeah. I've never had time to work on this library, but just an idea if anyone's keen. Yes, Iqbal.
Just a small thing, you can also configure a logger for your SQL queries that you can
That's true.
redirect
That-
to a file so you can get in.
Yep. That's very useful if you debugging your code, running your code in debugger. You can also see them in the log output. Thanks, Iqbal. Cool. Basically, the one thing that I want to talk more today is slow libraries. There are some libraries that provide you with rich interface, but they are actually pretty slow. In our case, it was Arrow. Now it's famous for its slow performance, and I think I would not recommend using it for new projects. Another library that we used was Cerberus. That we use it for quite to run validation logic, like custom validation logic on JSON blobs that we store in the database. And originally the use case was quite limited, but over time, the scope of the application increased, and at some stage we realized that both of these libraries are contributing 15% to our total response time. So the function that validates this custom blobs was taking 15% of the response time, and that was shocking to everyone. And we initiated a couple of projects, so we solved the kind of one problem pretty fast. We replaced, so we used Arrow to validate some dates, to run some custom date validations. And we replaced it with the small library that was only performing these validations that we need. I just was performing parsing, and we implemented validations that we need ourselves. And in case of Cerberus, we currently replacing it with JSON schema. It's in the core of our project, so it was quite complex. Quite complex project that one of my colleagues worked on, but we're close to launching this, switching all the endpoints to JSON schema now. And Pydantic is can provide even better performance, but in our case, it is impossible to use Pydantic because this validation schemas, they are stored in database, not in source code. So we couldn't find a nice way of creating Pydantic validation schemas from JSON schemas. Finally, I want to mention some libraries that are especially dangerous, and they are located in a very in a place that is very critical for performance. And last year we had a major performance degradation with New Relic Python agent. We just upgraded the library, and back at the time, we didn't. We still don't run performance tests as a part of our CI/CD pipeline, which we only planning to do this year. But back at the time, we didn't have nice performance test that basically testing that up, and we saw quite significant increase in response time, and it was a problem with the New Relic agent itself. And moreover, this year we worked on a new application that is very CPU bound, and we realized that New Relic agent is actually adding 30% to the performance, to the response time, or 90 millisecond overall. And we, after trying to solve this issue for a few weeks with the New Relic support team, the official response that we received from them is that it is okay. This is something that is expected, which I don't think it is. Anyway, that was my last slide for today, and I just want to quickly cover some things that was not included in the scope. So the other two optimizations that I wanted originally include and removed was caching and database indexing. Probably simple forms of it could be explained quite easily, but if we speak about advanced caching techniques, that's a large topic that probably can be expanded in a separate presentation. The same with database indexes. You can use them relatively easy. If you're not using database indexes, adding them is easy and you can receive benefits fast. But when it goes to optimizing, there is much more questions like what type of database indexes to use, like partial database indexes. You need to consider the index size and many things. So it's also probably a good topic for a separate talk. The other things that we did with application, we implemented multiple databases. When I say multiple, I don't mean replicas. It's like we store different types of data in different databases. And this usage patterns for these databases are very, very different. So we, by implementing this split, we actually were able to achieve quite significant improvement in performance and response time. And this is the same, and we were lucky that Instagram also used Django back at the time, because they implemented a lot of nice features that allows developers, users to work easily with multiple databases, and that was very handy for us. It's probably also a good topic for a separate presentation. Yeah, I won't go until the end of this list. There are much more things that you can do to improve performance. My goal wasn't to cover all of them. In general, working on performance takes time. It takes time to understand the workloads, to understand the internal parts of your application, and so on and so forth. And it takes time to fix those issues. So we had to dedicate separate engineers to work on these performance issues, because just the pace of changes that we add in our application is really high, and it's really hard to pull this complex performance optimizations projects in your day-to-day routines when you need to provide some support and when you need to provide implementation for the new features. Just before we wrap up, I want to do a quick quiz. Please raise your hand if you learned at least one new thing today. Cool. Thank you very much. That's it. I'm happy to take questions. I might need help, but I don't know how this thing really works. Thanks, Aaron.
I don't know if it's a question, but a comment. And, one of those things when you get asked a question, you give an answer after. One of the things that I hate, was you reminded me when you put up the bulk update, was that in Django, when you're trying to record a timestamp, when you use bulk update, it stops recording the timestamp on the database rows.
Right.
One of the things that really pissed me off.
Yeah. Yes, unfortunately, because this is happening in Python, and bulk update is using database skills. So yeah, there might be some problems. Not always all of that things will work straight away. Sometimes you need to. Of course, you need to factor in your specific use case, but in general, this is the simpler ways of improving performance. All other things that were on the last slide, they are much harder in implementation and take more time.
And another quick one, like bulk update, bulk create, that doesn't work well with signals. So if you've got like signal receivers that do stuff, then all of that stuff gets bypassed.
Yeah. Also, be careful not overusing signals. Yeah. Aaron can tell you more about that. but yeah, sometimes signals have a good benefit of decoupling your code, but sometimes it makes the overall structure much easier much harder to understand, and it can cause also performance issue because you simply don't realize, okay, there is this other thing that is called in this request.
You still use New
Unfortunately, yes. we started speaking to Datadog now. It looks like Datadog is using different approach. So if in New Relic Python agent, they actually collect all the data and send it to New Relic endpoints in Python itself. In case of Datadog, they have a separate component that you need to deploy in your Kubernetes cluster that basically is responsible for sending the data, and then your application is just and then just Python agent, it just instrument your libraries. So we don't know yet if it's faster for the specific use case. But in general, the feedback that I heard from other developers is that APM tools are adding quite significant penalties in some cases, and which hard to solve. By the way, we don't see those penalties happening in more IO-bound applications. Those like we measured, so we have a way. So we have a way of measuring performance in the ingress controller response time, and then we just can switch on and off the New Relic in the application. So we did this exercise on 2 applications that actually share quite significant part of the code base, but one application is more IO bound, another one is like very CPU bound, like mostly CPU bound, and the IO bound application doesn't show any impact on the response time at all. But yeah, so it looks like the problem that we're having is only with CPU bound workloads applications.
There's some debug primitives in Python 3.12, the new Datadog agents also take about it.
Yeah, right. So this is what I was hoping New Relic will implement. But when we spoke to the Datadog team, I was told that they have performance benchmark as a part of their user acceptance criteria for the tasks when they add in new features. I'm not sure if New Relic does the same, but I think it's a must-have of for APM libraries. More questions?
Yeah, maybe with the ORM, you mentioned that it could fetch automatically the database to do, fetch automatically some things with the database. Can you just disable that and just get the prefetching mandatory?
Make the prefetching mandatory. You need to be careful with prefetching because not always that makes sense. If you unnecessarily use prefetching, it also will be harmful to the application performance. How to, potentially, if there is a way to figure out from your serializer somehow that you need to use prefetch. I don't know, I haven't thought about this problem, but maybe there are some libraries that does that.
There is a library that does that.
Yeah, which one?
That prefetches the objects.
Really? Yeah.
Yeah.
What? Can you share like in Slack or? Yeah, just very interested. Yeah. Yep.
I think in the async context, you can actually tell it doesn't even work. These if you don't prefetch it, if you do on if you try to get a reverse foreign key relation, you try to access that in the async context, it doesn't even work. You have to prefetch it first. I remember the last release, when they bring on the async abilities into the database layer. Or
Yep.
You have a slide about local development things and it's like Django toolbar.
Yep.
Like that. Where do you rank Django Silk on that scale?
To be honest, I haven't looked at Django Silk for a long time. I saw it has more stars than Django Developer Toolbars, like something like 6,000 stars. Probably there is a reason for this. I don't really know. For us, I think when we originally introduced Django Developer Toolbar, it was like 6 years ago when we just started the project. Back at the time, I think Silk was not that powerful yet in comparison to DDT, so that's why we didn't use it. And I think DDT does everything that we need, and that's why we're not looking at other libraries. But
I can add something. So the thing is that Django Debug Toolbar is only used in development. It comes with a very significant performance penalty,
right?
Because it kind of like adds 20 times the performance penalty,
right?
Because you're just trying to figure out how many queries are being run and stuff like that. With basically Django Silk, you can run it in production.
Okay.
Because it's more about aggregation stuff. So it can kind of like measure very low cost. Okay, on aggregate, how long does this query take? And basically, like where are the outliers? How long do they take? So and then it kind of like displays that on a dashboard. So if you
Okay.
don't have really good kind of like tooling to do that, and you don't have a lot of money, then Django Silk is right for you.
So it's not like match, like it's not match in terms of features. So Silk is like a separate framework.
Very aggregate monitoring and stuff like that.
Okay. Yeah, thanks for pointing out. I'll definitely have a look.
Or Django auto prefetch.
Django auto prefetch. Thank you very much. Yeah, I'll take a note of this.
We just implemented the library.
Yeah. Okay. If we, yep.
One of the slides that you mentioned there was like replacing slow libraries.
Yeah.
And how did you notice those other libraries that need to replace?
So in New Relic, we actually use New Relic. I don't remember how this feature exactly works, but it allows you to mark the parts of code that you want to measure. Then you can see them as a spans in the New Relic data. So that's basically the technique that we used. Yeah.
How you know, like which
Yeah.
this one is coming from that package.
Yeah. Yeah. Then New Relic shows you the breakdown by segments, and you can see like how many times that segment was called and what's the average, time execution time for that segment. Yeah.
My question is actually more around all the other slow discoveries and all the other slow libraries. How did you identify those other slow libraries?
We didn't know that's why we used them in the first place. But I think before there should be probably some improvement to our process when we pick up a new library. There should be probably some performance testing, like or benchmarking done before we commit into using this, at least for critical applications.
But I presume when you were looking at it, you're looking at something that took a long time. You're looking at where the time was spent.
Yeah.
You narrowed it down using your New Relic tool.
Yes.
Until you knew where to spend your effort.
Yeah, exactly. So the approach was that, we suspected some places in the applications being slower. So we put this additional marks in New Relic that allowed us to measure the performance. And then we collected some data, analyzed it, and we had some, surprising results. And then we started digging deeper and did some, I think, when Min is here, still here, I think when Min did some of the benchmarking, like specifically for the libraries, and showed already her results, like specific to those libraries, how fast they perform the code, and yeah.
You need to run it.
Like I'd say you could do this locally, but I would say it's much better to run it in production, because in your local environment you can't really simulate the production workload. So simply what's happening in prod might be very, very different to what's happening in your local environment. And especially in our use case, where a lot of configurations, they are stored in database, and then they pulled from the database and they impact the way how the logic runs. So, we have different products, insurance products. Some of them could be very simple, which have like very small number of rules. Some of them could be very complex, where much more validation and computations is, and in general business logic is happening. So it is better to measure those things in prod and then profile in your local environment once you kind of can narrow down the pain problems. Yeah.
You mentioned 50 million requests a day.
Yep.
What sort of infrastructure, like how big is the box? How many compute to use?
Yeah, so think we're using Kubernetes, and our nodes are can't remember what types of nodes we use at the moment, but it's two types. One of them is more like memory optimized. Another one is more like CPU optimized for different tasks. And we running approximately, during peak hours, we're running 160 containers. Each container would have 4 G-Unicorn workers. The application has, I think, we have right now like 2 GB memory consumed by 4 workers. It's synchronous workers, so memory is not shared. So 500 megabytes. I think it's the max limit. I think we using like less than half of that average. Yeah, I don't know what is it like. What else do you want to know? I'm not.
No, that's
Yeah.
It's just interesting.
Mhm.
How much.
Yeah. Yeah.
But like, do you kind of like, so I think it because you're a very high performance app, you need to kind of like measure everything. So like any good tools about measuring the memory footprint of various different libraries? Because if you have one worker with 512 MB of RAM, that's a lot basically. So it's like you probably have a lot of stuff going on.
Yeah, the reason why the application consumes so much memory because we use quite a lot of memory caching. Like we cache multiple configurations, because if you think about that, insurance product very rarely changes. So in theory, you can take that object from the database and just put in memory, and it will be much faster than pulling it out on every request. Then it takes time to create the instances, map all the data. So yeah, that's a good optimization, and we use it in addition to shared cache quite significantly. But yeah, if we look overall on our nodes, I think our nodes mostly have a lot of free memory. So we can increase it even more and for free if needed. But yeah. Configuration changes, you mean in? Yeah. Do you mean how we invalidate cache? Yeah. So most of the time, our products are not launched when someone clicks the button in the UI. They became active at some date in the future. So we have a very simple invalidation strategy, which is just invalidate by timeout. That's it. So we cache it for, I think, 10 or 15 minutes, and that's more than enough to accommodate all the different use cases. It's rarely, it never gave us any problem in production, because yeah, most of the time, changes in the product, they are scheduled for the future date, because the insurance product, are regulated. So all of those changes, there's quite complex process before those changes go actually in production. Yeah. Yep. We probably need to wrap up. It's already quite late on the schedule, but I want to thank everyone for coming today, and stay connected. Hopefully, Slack website, you can find updates there, and hopefully we will be able to announce our next event soon. It's probably not going to happen next month, but we are intended to run more events this year. So yeah, stay tuned. Thanks, everyone.
Welcome.
Yeah.